Hi guys, I am Dr. Nandapology. Today we are discuss about the topic of crystal structures, Bravais Lattice, and directions and planes in crystals. First of all, we are know the crystal structure, single crystals, and seven different types of crystal structures, cubic structure, and tetragonal, hexagonal. These type of seven different types of crystals, seven crystal systems, and parameters like as A, B, C, like edges, and alpha, beta, gamma, it's a angles, and it's a three-dimensional material. In this topic, we are discuss about the introduction of Bravais lattice and the classification of planes and the importance of directions and planes. First of all, importance of directions of crystals. First of all, it's a anisotropic of properties. Many properties of crystal like as electrical, thermal, optical, and mechanical are directions dependent. Example like as thermal conductivity in graphite is much higher along the layers than across them. And slip systems in deformation. Plastic deformation occurs more easily along certain crystallographic directions. Example in metals like FC is if face center cubic structure slip occurs along 110 directions on 111 plane. Growth of crystals, crystal grow faster in some directions than others, leading to specific external shapes like as morphologicals. Example, quartz crystal grow elongated along the C-axis. Transport properties, electron and ion movement in solids depends on the direction of the lattice. Example like a silicon's electrical conductivity in different along 100 as triple one plane. Importance for semiconductor device designs. X-ray directions, X-ray diffraction and material characterization. Knowledge of crystal direction is essential for interpreting the diffraction patterns and determining lattice structures. In the figure shows the X-ray diffraction pattern image. And then Bravais lattice in 1948, Bravais showed 14 types of unit cell under 7 crystal systems. In the possible ratio of simple cubic structure like as simple cubic structure, face center cubic structure, and body center cubic structures are available in cubic structures. In tetragonal like a simple and body center cubic structure only available. In hexagonal, no more these structures are available. Orthorhombic structure like a simple orthorhombic structure, body centered orthorhombic, and base center orthorhombic structure, and face center orthorhombic structure. In the rhombohedral like as a different face value, and monoclinic like a simple and base centered. Triclinic like as a different types of centered values. In the indices in this Bravais lattice, Miller indices gives directions and planes of crystals. The crystal have a three-dimension structure, so x, y, z directions we are identified. In figure 1, 0, 0, 1, like as z axis only the crystals are formed. 0, 0, 1, the blue color is indicated in the figure 1, and 1, 0, 0 x-axis only indicated, and 0, 1, 0 y-axis only indicated. In the second row, the 1, 0, 1 like as x-axis have a point and z-axis have a point. So the shadows are the drawn in the cross sections, and the x and y direction like as 1, 1, 0 planes like as the green shadowed planes, and 0, 1, 1 see x-axis as 0, and y and z-axis only the plane structures. So the second row third image shown in the 0, 1, 1 plane structure, and x y z three directions are shown in the third row of the diagram. 1 1 1 plane. If opposite directions of plane like as 1 inverse, like as the 1 inverse 1 1 1 1 1 inverse, like as the third image. In the practical applications of the directions like as semiconductors, silicon wafers are cut along specific plans. This ensures optimal electronic performance. In the material design, understanding crystal structures enables alloy designs. It optimizes strength and uh, duality, like as ion materials and like alloy materials. And paramedicals like as crystal structures impact drug solubility in affect drug efficiency and bioavailability. Approximately 90% of small molecule drugs are crystallines. It's like as a critical for performance. In this practice, lattice and directions of planes gives different roles. In the directions, planes has orientations and normal predictions and notations and Miller indices structures. And Bravais lattice like as absolute work natures and relative to another types and Miller indices and tetragonals. And in the curiosity of the how many types of Bravais lattice